Any small ones or what?
What do you notice?
Well, we said in the first picture they're moving to a.
What's they? Molecules of what? Water? Okay.
They're moving to like a higher concentration.
High concentration of what?
Of more molecules. Going from high to low.
Okay, from high to low what though? You do know. Okay, keep thinking. Just keep talking. Concentration of what? Like, you said the water's moving. So keep going with that. Where did the water move in this picture? Show me.
To the ones with more.
Okay, so it moved to the ones with more
Water and molecules.
So this one has more water? And the water came from here? Why did it go over there?
To even out the like concentration between the what do you say, the molecules in the water.
Okay, so you're saying like the dots are the molecules. So because you don't know what it is. Do you need to have them label that? Does it matter? Like, was that important for them to tell you what the dots are? Are you okay with, could you answer a question if it just looked like that?
If it'd be nice. I think if the question was simple enough, I think you could.
Okay, because you'll notice I took that off. Like, they obviously told you more and I took it off. But the way you're describing it is that the dots are the molecules and that water moved to the left. And you said it was to equal out?
Yeah, to make sure, like, to try to even out the number of the molecules in the water, like the
Okay,
the
will you put
amount.
that in your quick write, and when we come back together, because that's a really important point, and I want to be sure we talk about that as a group. So when we get to our quick write, so you can just keep going. And have you gotten to this one yet?
No, we're still talking about two.
So what have you noticed?
I guess it's 1, 2, 3, or 1, 2, and 4. The water.
Okay, speak up a little bit so I can hear you. 1, 2, and 4.
The water moves. The water's the ones that moves
The molecules don't move.
Okay, does it matter that I kind of cut off on purpose, like what the stuff is? Could you? Okay, so you don't
Because
have
it's
to
going
have
from
that.
like, yeah, the water's moving from a low concentration to a high concentration.
Of
It's more distributed.
whatever that stuff is.
Yeah.
And so we really don't have to know that. So what happened with 3? You said water moved in 1, 2, and 4.
And then the small molecules went to the larger molecules. So it's more distributed. And you have like more water for the, I'm not entirely sure why it's like that, because I feel like,
So you're, okay, so say that again. So the third one is different because,
It's only permeable to the water and the small molecules, not the big molecules.
okay, so this one is different because there's, I haven't heard you say small and big. Like the rest of them don't have small and big, right? They just have the one type. So this has 2 different solids in it. And so what would you say about this membrane?
It's semi-permeable.
Okay, and it's going to be semi-permeable to, what's it permeable to? Yes. To the red molecule, yeah, whatever they are, we don't care. And the water, right? But not the, whatever color that is, purple. Okay, so this one's a little different from the others. But if you had a test question like that, you could still write about what you saw.
On number 2, where it says it's a semi-permeable membrane, does that mean it's only permeable to water since none of the molecules?
And they didn't tell you. Actually, I think I cut stuff off on that one, that it might have. Because my point of this was to say, bare minimum, like if they gave you just this, could you still figure it out? And you're doing a great job with that. So what would you say to your own question? Like,
Well, so judging like the number of molecules are still on that one side, it doesn't appear like they can go through, therefore it's only permeable to water.
and the other evidence for that, what else is different between like this side and this side?
The water.
The height of the water, right? So that also gives evidence to what you were saying, that water moved, but that the solute didn't. Those are good observations. Okay, so can we go ahead and do our quick write now? So go ahead and do that. You have 1 minute. Everything you're thinking that you just said, Like if you were saying, oh my goodness, this is what this woman's gonna read, because it is, I wanna be sure she knows I understand this. You may even wanna start with, I understand that, and then write what you understand from the figures. And you have a minute. Just as quick as you can write it. 1 minute. Okay, so get to where you're finishing up your thoughts. So whatever sentence you're writing, finish that up. Okay, so what I want you to do now, I've given you a second task. These are the ones with the dialysis bags drawn much better than I do. And I want you to look at this in the same way. So look from initial to final for problem 1 and problem 2, and then compare the two, and then go back and compare these to task 1 as well. And just think about how they're representing the same processes. So you've got the second task, and I'll come around and listen to your conversations.
On this one,
The X's are able to come in and the dots are leaving, so they're free to go in and out of
What's free?
the molecules in the water. I don't know if they.
So which one, okay, so obviously they didn't label anything. This one's a little bit more labeled. This one I took all the labels off. So what do you think the X's are?
Like,
glucose maybe.
Water, it could be glucose, okay, it could be, does it matter? Okay, it probably, okay, that's the point, it doesn't matter. So keep going with what you were saying they could, what ones could.
so the X's, they're able to move into the dialysis bag, like they can come in freely, and the dots are able to leave the bag as they want. Yeah, circles, yeah, they're circles, yeah.
So this is more like what question you had? Okay, so if you have one that has 2 solutes, it's not really any harder than having just one. Okay, that's what I'm not hearing anybody struggle with it. Because, you know, we've had the test questions where they'll say this is permeable to this but not this. I think the figures are a little easier than the words. Okay, so what do you notice is going on? Let's hear what this group says about the second one.
Well, it looks like at the start dialysis, there's no solution except probably just water, whatever the liquid is outside of the dialysis bag. But in the final concentration, it looks like the blue dots can't pass the membrane, and the red ones can. And so the red ones make equilibrium both outside and inside the bag, but the blue ones must.
Okay, so you said something really important there, and I want you to be sure you put it in your quick write, and then I want us to talk about it, because you used the word equilibrium. So I'm going to ask you a question, and I'm going to leave, and I want you to think about it, and then when we come together, I'm going to ask you. When you say equilibrium, what exactly do you mean? Like, that's what I want y'all to talk about. Like, what exactly do you mean when you say equilibrium? So think about how you would let someone know. What'd you notice? Who said that it's like a question we had on the test? Okay.